Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 16 to 20 of the Geometry Common Core New York Regents exam for June 2016. Alright, let's take a look at question 16. It reads, on the set of axes below, rectangle ABCD can be proven congruent to rectangle KLM using which transformation? So is it a rotation, translation, reflection over the x-axis, or reflection over the y-axis? So when you think about rotations, you're thinking about spins happening around an axis. Translation is just a movement. Now when you're dealing with reflections, you're thinking about a mirror, okay? If y-axis is the line of reflection, the y-axis will act like a mirror, and same applies to the y-axis. Now if you look at this on transformation right here, do you see one of the axes acting as a mirror? If you take a look at the x-axis, this clearly is the axis of reflection, because if this were a mirror, this portion above will get reflected downwards and the portion below will get reflected upwards. So the answer to this is option number 3, a reflection about the x-axis. Okay, so let's go ahead and verify that real quick. Let's review our reflection formula. So what you want to remember is that if you have a reflection about the x-axis, write that again, reflection about the x-axis, if you reflect the point xy, what do you end up with? You end up with x comma negative y. All the y coordinates become the opposite sign. Okay? How about reflection about the y-axis on the coordinate xy? If you're reflecting about the y-axis, the signs of the x-coordinate flips. Okay, now let's just pick a test point here just for verification purposes. Point B is 1, 1, 2, 3, 4, 5, 1, 5. Okay, so the question is, what's the reflection of this point about the x-axis? What do we get? Reflection of 1, 5 about the x-axis simply means, following this formula, you negate the sign of y, and you end up with 1 comma negative 5. Now, based on this reflection right here, if B is the object, the image is going to be L. What is the coordinate of L? Let's look at it as 1, 1, 2, 3, 4, 5. 1 comma negative 5. Does it match what we have here? It certainly does. So we have confirmation that this is clearly a reflection about the x-axis. Okay, so this is the mirror. Another way you can think about it is, if you fold this graph along this line right here, what's going to happen? This point gets mapped perfectly to this one right here. This one gets mapped, C gets mapped to M, E gets mapped to K, and N gets mapped to D. Okay, so it's clearly a reflection about the x-axis. Alright, let's take a look at question 17. It reads, in the diagram below, segment DB, scroll up a little bit so you can see, segment DB and AF intersect at point C, and AD and FBE are drawn. Okay, AD and this line FDE right over here, the segment. If AC is 6, DC is 4, FC is 15, measure of angle D is 65, and measure of angle CBE, this exterior angle here, is 115. What is the length of CB? Okay, so let's populate the unknown side measure with the variable x. This is what we're looking for here. Now, one thing you want to keep in mind is the AA similarity postulate. What does the AA similarity postulate say? It says that if two angles of one triangle are congruent to two angles of another triangle, guess what? The two triangles are similar, and similarity implies that corresponding sides are in proportion. Okay, so let's keep that in mind. Now let's take a look at triangle ADC and triangle FBC. We can clearly see that this angle right here, DCA, is congruent to BCF. Okay, so let's write that down. Angle DCA is congruent to angle BCF. How do we know that? They are vertical angles, okay? Vertical angles. What do we know about vertical angles? Vertical angles are congruent. Okay, now we have this, something's happening here. CBE is 115, right? So if CBE is 115, it follows that CBF, this angle, is a supplement of 115, right? So CBF is going to be, so measure of angle CBF is simply going to be 180 minus 115. When you do the calculations, you have 10, 5. 17 minus 11 is 6. Damn, 65 degrees. What do you notice? We have another angle in triangle BCF congruent to another angle in triangle DCB. So this angle is congruent to this angle. Okay? So this angle of congruence right here counts as A. And then we have another pair of congruent angles. Angle ADC is congruent to angle F. So we have ADC, it's congruent to angle FBC. Okay? So by our calculations, we have that right there. They are congruent angles. Okay, so now we have A and then we have another A. What can we conclude? What can we conclude? We can easily conclude that these two triangles are similar by the AA similarity postulate. Okay, so let's write that down. Triangle ADC is similar to triangle FBC. That is by the AA similarity postulate. Okay, so what can we, how does this help us? Well, that means corresponding size and proportion. All right, we can set up proportions to solve this problem. So DC corresponds to BC, and AC corresponds to FC. Okay, so let's set up our statement of proportionality. So we're going to say, well, let's write it down first. So DC over DC over FC. So DC is this side right here of the small triangle. So DC over DC over BC, I can use the letters to guide me. DC over BC is equal to what? Is equal to AC. So AC over what? FC. Okay? Based on, since the two triangles are similar. All right? Now let's put in the values in our proportion right here. DC is 4. BC is our unknown x. AC is 6. And then FC is 15. Bam. Okay, so just solving this proportion for x will give us the answer. Okay, let me put a reason here. Triangle ADC is similar to triangle FBC, right? So that implies that corresponding sides are in proportion. Just to help you know what I'm thinking, okay? All right, let's solve this. So since we have a variable downstairs here, we can simply cross multiply. Denominator on the left to the numerator on the right, denominator on the right to the numerator on the left. So you cross multiply to get 4 times 15 equals 6 times x. Okay? So what does this yield? 4 times 15 is 60 equals 6x. Let's isolate the variable x by dividing both sides by 6. Our final result is going to be x equals 10. Alright, answer for number 17 is option number 1. Alright, let's take a look at question 18. It says seawater contains approximately 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? Okay, so this problem involves setting up proportions. One tip concerning setting up proportions that have units is that you always want to keep track of your units when setting up your proportions and keep them grouped together. Okay, if you so let's take a look at this scenario here. We have ounces, liters. Well, let me color code it so you understand what is going on. So we have ounces, liter, and then we have, what else do we have? Gallons and pounds. So gallons, well, let me switch the color. And gallons and pounds. So we have they kind of switch the order of the units. So gallons and pounds. Okay, so ounces and pound, those are what? Those are units for what? For weight, right? Gallons and liters are units for what? They're units for volume. So when you're setting up your proportion, you want to ensure consistency. Are your volumes in the numerator? Then make sure they're in the numerator, and then keep your weights in the denominator, however you want to set it up. Okay? So let's go ahead and put that notation down real quick. All right. So what do we have here? We're gonna say ounces. So let's put a side note here. Ounces, and we have ounces and pound are units of what? Of weight. Now, if you look at your reference sheet, it also assists you in that regard. If you look at a reference sheet, I grabbed this from your Regents exam. See these units right here? These units clustered together here. These are your units for weight. Okay? And then another thing you want to note is that concerning the units is that liter and gallons, liter and gallons are units of what? They are units of volume. Okay, and then if you consult your reference sheet, you see that. See, you have gallons here, liter and gallon. All these units over here, they are all units of volume. Okay, so this is unit of volume. All right, now in this problem, it's good to start from the end. Okay, look at what you are looking for, so that will help you set up your conversion factors. We are looking for how many gallons in 1 pound. So that's gallons per pound. Okay, so what we're looking for is to find x gallons per 1 pound. Okay, so what do you notice here? In this problem, we have what we're looking for is basically volume in the numerator per weight in the denominator. Okay, so when I'm setting up my conversion factor and I start converting to this unit, I want to put the volume on top and weight on the bottom. Okay, so that's very important, or else you end up with the reciprocal of your desired result. Okay, so we know that we have 1.2 ounces per 1.2 ounces per what? 1.2 ounces per liter for every 1 liter. Okay, this is what? Ounces is a unit of weight, and this one is the unit of volume. Is this a setup that we want? No, we're going to reciprocate it. Okay, I want volume on the top and weight on the bottom. So after conversion, I will end up with volume on the top and weight on the bottom. So this automatically implies that, just by reciprocation, that 1 liter per what? Per 1.2 ounces. Okay, now this is a unit I like. This is volume per weight. Okay, in this problem they kind of switched it around, which is kind of weird, but anyway, so this is the setup I'm going to be using. So now the task is convert 1 liter per 1.2 ounces into gallons per pound. Okay, so we're going to convert 1 liter per 1.2 ounces into gallons per pound. Okay. All right. So all we're just going to do is use the formulas from our reference sheet, and that was sisters. Okay. So 1 liter per 1.2 ounces. I want liter gone. I want it replaced with the measure of volume, namely gallons. So I'm going to go to my reference sheet, and I want to pick the formula that has liter and gallons. That will be my conversion factor. Okay, so this is the one we're using right here. 1 liter per 0.264 gallons. So how do I set it up? I want liter gone and I want gallon left. So guess what? I'm going to put liter on the bottom here and gallons on top. Why? Check this out. The liters cancel out, and then you're left with gallons. Okay, so from the conversion factor we just looked at, let me see, I already forgot what it is. 1 liter, 0.264. 1 liter is 0.264 gallons. Okay, so this multiplying by this conversion factor changes this to gallons per ounces because this cancel out. Okay, but we're also we want our unit of weight to be pounds. Okay, so now how do I set it up? How do I set this one up? I want ounces to cancel out, and I want pound in the denominator. All right, so I'm going to have, I want ounces to cancel out, so since there's ounces here, I'll put ounces up here, and I want to convert ounces into pounds. Okay, so ounces per pound. So I'm going to go back to my reference sheet and ask myself how many ounces per pound, or how many pound per ounce, whatever, it doesn't matter. So go to your weight conversion factors and look for the one that has ounces and pounds. So bam, there you go. 1 pound is equal to 16 ounces. This is kind of like a physics problem. Anyway, okay, or chemistry. So we come over here. 1 pound is 16 ounces. So you have 1 pound, 16 ounces, like that. Okay, now what we're going to do is watch the units cancel out. This must happen. You must end up with your target units in order for you to know that your answer is correct. If you do not end up with gallons per pound upon cancellation, then you have to reconstruct your conversion factors. Okay, check this out. Liters cancel out with liter. Ounces cancel out with ounces. What am I left with? Gallons per pound. Perfect. So I'm going to have 1 times 0.264 times 16 ounces per what? 1.2 pounds. Okay, all we do now is plug this into the calculator, and that should give us the final result. Okay, so we have, don't bother with the 1.264 times 16 divided by 1.2, 3.52. Okay, so it's going to be equal to 3.52. 3.52 ounces per pound. or pound. The problem asked us to round it to the nearest tenth of a gallon. So we're rounding to the first decimal place. Okay, so your answer is going to be 3.5 um, ounces per pound. Ounces per 1 pound. Okay, and the correct answer, let me box my result. Correct answer is option number 2. Okay, let's take a look at question number 19. It says line segment EA is the perpendicular bisector of ZT, and ZE and TE are drawn. Okay, now which construction cannot be proven? Okay, one thing I want you to keep in mind, quick reminder, is that the altitude of isosceles triangles bisects vertex angles. Okay? Alright, while we're talking about isosceles triangles, let me go ahead and show you something cool about this problem. If EA is a perpendicular bisector, it tells us two things. Okay, two things about these two triangles. If it is a perpendicular bisector, it tells us that ZA is congruent to TA. Okay, and then this is 90 degrees. This angle is congruent to this angle. They're a linear pair. Okay, and then by the reflexive property of congruence, this side is congruent to this side. What do we have here? We have two congruent triangles. Okay, let me write down my reasoning real quick. So ZT is congruent to TA, okay, by bisection. Based on the definition of a bisector, and then EA, let's put my notation correctly. EA is congruent to EA using the reflexive property of congruence. And then what do we have? Angle EAZ is congruent to angle EAT. Okay? This is because they're by bisection. Okay, bisector. Alright, there are bisectors. If you bisect an angle, you're going to be left with two congruent angles. They're both 90 degrees. So what we have, ladies and gentlemen, is SAS. So based on the SAS congruency postulate, triangle EAZ is congruent to triangle EAT. Okay? SAS congruency postulate. Alright, so what else can we conclude if we have two triangles that are congruent? Can we conclude that ET is congruent to EZ? The answer is yes, because congruent parts of congruent triangles are congruent. Alright, so EZ is congruent to ET, segment ET. Okay, CPC to C. Okay, so what kind of triangle do we have here? This side is congruent to this side. We have for triangle, the entire triangle, okay, triangle EZT is, guess what? An isosceles triangle. Isosceles. Let me fix my spelling real quick. Okay, so it's an isosceles triangle because it has one pair of congruent sides. Okay. All right. So let's go over here and see which of the statements cannot be proven. So it says EA bisects angle Z. EA bisects angle ZET. What did we talk about earlier? This segment EA is known as the altitude of our triangle. Okay, altitude. It goes from the extended base perpendicular to the extended base and intersects the vertex opposite the perpendicular base. That's the altitude. We know that altitudes of isosceles triangles bisect vertex angles, so it has to bisect this angle. This angle here has to be congruent to this angle here. Okay? That's a fact since this is an isosceles triangle, so this is check. Option 2, wait a minute, triangle AZT is equilateral? No. Triangle AZT is isosceles, so this cannot be proven. The answer is option number 2. Okay, let's take a look at question 20, the last one in this review installment. It says a hemispherical water tank has an inside diameter of 10 feet. If water has a density of 62 pounds per cubic foot, what is the weight of the water in a full tank to the nearest pound? Okay, there are 2 words of caution for this problem I want you to pay close attention to. And this has to do with volumes of objects with circular outlines, like spheres or cylinders, cylindrical prisms, circular prisms or cylinders, and also hemispheres. Okay? First one, volume. Now, whenever you're calculating the volume of circular objects, make sure you are using the radius. Okay? One mistake most students make is they don't pay attention to that and they end up plugging the diameter into the radius position in the formula and they get the answer wrong. So make sure that what you're plugging in is actually the radius. Number 2, a hemisphere is half of a sphere. Okay, so when you're using the formula, you have to apply this adjustment factor here. You have to divide your formula by 1/2. I'm sorry, divide it by 2 or multiply it by 1/2. Okay? All right, so let's go ahead and take a look at this problem right here. So we are given the density and we're asked to find the weight or mass. What formula relates the density and the mass? This is the formula you need to know to do this problem. The formula is density equals mass over volume, dmv. Okay, so you can write it as d equals m over v. This is what I'm going to be using. So in this problem, we know that the density is 62.4. We're asked to find the mass. The mass is unknown. What's the volume? What's the volume of a hemisphere? We don't know it, right? But can we find it? Yes, we can find the volume with the given information, and then we can then proceed to compute what the mass is using this formula. All right? So let's go ahead and find the volume first. Okay, so let's find V. We're finding the volume of what? We're finding the volume of a hemispherical of a hemisphere. Okay, so there goes the sketch of my hemisphere right there. That's a half of a sphere. So we want to find the volume of this. So we're told that the what are we told? The diameter is 10 feet. Okay, so if you're going from here to here, that's the diameter, which is 10 feet, which is equal to 10. The volume of a hemisphere is half of the volume of a sphere, so it's going to be 1/2 of the volume of a sphere, which is 4/3 pi r cubed. Okay. Alright, so to calculate the volume of this hemisphere right here, let's call it volume of hemi. What are we going to do? So remember this 1/2 I talked about earlier is because the sphere is half of a hemisphere is half of a sphere. Okay, so it's going to be 1/2 times 4/3 pi. What do I put in for r? Do I put in 10? The answer is no. Remember, the warning earlier is that you want to make sure that what you're plugging in is the radius. You were given the diameter, so if you're not paying attention, you might just, hurry through the problem and just put a 10 here, and that will be wrong. Okay, we need to find what the radius is. The radius is the distance from the center to the circumference. So the radius is half of the diameter, right? So it's 10 over 2, which is equal to 5. So that's what we plug in here, 5 to the third power. Okay? All right, so let's put that in our calculators. So we'll have, what do we have? Clear that. 1 over 2, 1/2, times 4 divided by 3 times pi times 5 raised to the third power, 5 caret 3, or you can use the cubic option somewhere here. I don't know where it is. Okay, enter. So we have 261.7993. So that's the volume of the hemisphere. So volume is going to be 261.7993. Okay? It's going to be in cubic foot. All right, so are we done with the problem? Is that what we're looking for? The answer is no. Remember, we're looking for the mass, okay? So density is equal to mass over volume. We now know our density and our volume. Now we need to find the mass, okay? So density is 62.4. That was given to us. The mass is what we're looking for. And the volume is what we just found, 261.7993 cubic foot. To get the mass by itself, we multiply both sides by the denominator here. 261.7993, 261.7993. Let's cancels out, and we end up with the mass. Let's have a calculator do the work for us. So where are you? So just simply multiply that result we got by 62.4, and your final answer is 1,633. I mean 16,336.2818. So let's write that down. 16,336.2818. Yes, 2818. All right, we're asked to round it to the nearest pound. Okay, so we're rounding it to the ones place right here. So the number behind the ones place is 2, which is less than 5. So we're going to round down. So we're going to have the mass, or the weight. The weight is equal to 16,336 pounds to the nearest what? Pound. Okay, so there goes our answer. So the correct answer is option number 1. Option 1 is the correct answer for this problem. Thanks so much for taking the time to watch this presentation. We really appreciate it. Please help support our work by giving us a thumbs up. Your positive feedback is very, very important to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. More clips can be found on Mathgotserved.com. Thanks again for watching, and have an amazing day.